Bismillahirrahmanirrahim. Assalamu alaikum everyone. Welcome to recurrent neural network and LSTM session. And today I want to cover like introduction of RNN, why we use or what it is important, real time use case of RNN, and finally we'll talk about LSTM. First of all, RNN is a family of neural network, and the biggest update or the modification is that RNN work with specifically in the sequence data. So if we look at this vanilla RNN architecture, you can see that there is an output denoted by HT. Also another output is part again it's circular inside A, and another with XT. It means that in the during the time stamp each word or data. So if we extended this, we can see that uh, the below one is x0, x1, x2, which represented the alongside each word with the tax time, and above one. So you can see that each input pass through the RNN. This is considered like a black box. Inside this, it goes one output and another output from hidden state with go this one next input what previous output. So also the sequences matter because you cannot perform x1 before x0. Similarly, you cannot perform x2 without you have x1 or x0. Uh, so what happened actually in our traditional data? In traditional deep learning, there has a set of input and work independent time. No segment is dependent with the time, and also the traditional deep learning model like uh, consider just only we have three models so far: artificial neural network, convolution neural network, and recurrent neural network. So these two we see that they didn't rely on the previous value or what will happen in the future. They don't care. During the running time they are independent, they have no segment. uh, okay, we will see later about this. So look like how look like the actually architecture of ANN. I attached two picture here. One is vanilla RNN, another is extended version of RNN. Though there has a numerous advantages of RNN, also it has a drawback that it cannot recall many long time. That's why we need more memory. We know that whenever we want to store something we need memory. So LSTM is an extended version of RNN, so where it store or it memory work better than vanilla RNN. So here is an visual animation how actually RNN works. So here denote H, it is a hidden state, and you see that if you look at that the below, and each time step against one output that is denoted by y. And if you look at this that like here, mm, every this C, every state has passed this C, so it is means that they share same parameter. Okay, so what is the real use case of RNN? Well, first of all, uh, you can see that the Apple Tree, Google voice search, predicting stock market price, generating text and text to speech, as well as name entity recognition. So RNN basically focus on NLP domain, and these all are see here related about NLP. And without this, there are a lot of work that directly involved RNN. And after introduce RNN for sequence data, it created a lot of impact in the deep learning era. Once again, I told you that nowadays there are so far advanced model available for sequential data. They outperform than RNN. So we consider that we have only three model. Okay, we have no GPT or um, any sort of advanced transformer model. We have only three model: ANN, CNN, and RNN. Among them, which one is better for sequential data? And every day we know that there are a lot of data that are sequential. So obviously, we know there are some advantage and disadvantage of RNN. The first advantage is that it deal with variable length sequence. So variable length sequence means that, for example, if your data set it has a number of word. Okay, look at this. Here you can see that the first sentence length approximately 5, and in the third sentence length 2. So we know in ANN or CNN we must be past the fixed size. Here the great advantage is that there is no fixed size, and it recall previous input after parameter sharing and sequential processing. And another great disadvantage is that vanishing and exploding gradient. Basically, the vanishing uh, problem occurs when we back propagation, and we know that back propagation we can update our model weights. And every traditional deep learning model that was the very challenging, and the problem is occur. Another one is computational complexity. So I want to add something about vanishing and exploding. Whenever we want to perform the back propagation, if we see that the value is going to uh, nearest zero, and it cannot update any weights, the that time we call that it is vanishing gradient descent. And if whenever we want to apply back propagation, and if the gradient value is more than the current, I mean, uh, our goal is to reduce the weight size, rather it can increase. So this is called exploding gradient. And yeah, there are few types of RNN available. These are one to one, one to many, and many to many. uh, so we can see that the use case of first one is the vanilla uh, RNN. So this is very straightforward. We pass a single input and got a single output. That is considered general machine learning problem. And one to many. So we pass one single input uh, with based on this we got multiple output. Basically we see this type of application is are like the image caption generate or music synthesis. We just insert one data, uh, get many output, many to one. uh, well, so this is a reverse of one to many. Here we use multiple input and got one output. In this sentiment analysis, we must like if we consider a movie review, so we must insert 3 to 4 sentences rather than we just got one output like the movie is good or bad. And the final one, many to many RNN. So each input has each output. So basically we can see this when the language translate. For example, if I want to convert this one language to another language, the time it can change each time stamp. So now LSTM, it's capable of long-term dependencies. It can recall a word for simplicity. It can record a for long period that more than the simple RNN. So as it is an extended version of RNN, so today's my main focus is how an RNN works and how it differs from the CNN and ANN model. So here's the reference for my slide, and I want to now share with that how actually RNN works. Not we do not select. Okay, so let's start from here. So what is this example? This graph we can show that this is a stock price marketing, and the graph we can see here that there is a sequence. So like the number of year. So the sequences matter. Like if someone said that you have 2013 to 2015 and you have 2018 to 19, this data, and then someone said like you can predict 2017. So this is not in real time uh, possible, or like the meaningless. We know that 2017 must become before 2018. So the sequences matter. So also if I like follow this curve, it gradually fluctuated and increasing, and here it is much more than previous one. So there is a huge pattern here. So for clear understanding we must need the full data in a sequence. And another one is this is an audio signal. I hope you all are know that how actually audio signals in looks like. So if someone removed this and told you that hear the audio and tell me what you hear, you may lose you you definitely lose gr- most important news or important information. So that's why we need a sequence. And this is the one of the two example of sequence data. There are so many available in the world. So let's start with how why we do not choose ANN rather than we select RNN. Why not NN? As we know that NN work also tabular data. Okay, I want to add something here like CNN is great for image data. Well, we can perform convolution 1D for tabular data, but it cannot suit for this. So I ignore this here, but we know that in the ANN it can work perfectly tabular data. So why would we need RNN as we having CNN? Well, so the problem is actually happening is that so we know that in the NN, so it is a feed forward, a simple feed forward network. So here it never bothering about the past and future. It just work currently, and one each hidden layer input layer, then it goes to hidden layer and then output. It never consider from here to what was the previous one or what will be the next one. So we cannot perform here. And another thing is that like consider this is my features data. So these three together pass here at a time. It pass here, so it never consider like uh, separated one. So instead of in RNN, what happened? Firstly goes apple. After completion, this then go to the is and then go to the end. So you can see that there a is connected with the apple and it is connected with this previous one. So this one is another big difference between NN and RNN. uh, Also, how do you pass? Okay, I want to say something here. First of all, we need this word to vector. There are many ways we can do perform. Among them, one one uh, way is uh, one hot coding. We can change it. We will show in the next section that how we can perform vectorization, tokenization, each and everything in the next session. And here I want to show some the hands-on actually how it actually works. Uh, so one major example we find that RNN train uh, step by step and ANN works togetherly. Uh, so now let's look at this. So one vector. First of all, it calculate how many distinct word here. Let's say I say that 10. 10 is the vocabulary. So the vocabulary list like this, uh, length will be 10, but first one, I mean this is 10. So it represent apple. And what is my next word? Is. So is represented like this. Rest of are 0. And then we have good. So you can assume that when the word is 10th word come, so everyone is 0 and the last one. So here you can see that each one has is there one shown in the vector. And well, also okay. So the next portion is that there is a great problem between ANN and RNN. RNN can work with fixed length data, but ANN cannot. So you have a question come that I can solve it like these three. Okay, I pass. So and here, if you look this, the length is 5. So you know that artificial neural network cannot perform well in the variance length. So you may be told that I make every sentence length 5, with adding zero padding. Zero padding means nothing, just extra block add with zero. So you tell that for this one you add two zero padding. Consider here is the length 4, so you need one. So uh, this is not a good when the data set is going to be large. For example, you train fixed 5. So what happened? Now the next sentence is like sixth length or 10th length. So what should you do, or how do you update this? So you cannot easily do this. So this is one of the problem. And and that's why we need RNN, which do well for variance length. If the sentence length is 3 or 30, don't do not create bother. As I already told you that first it goes to the input T1, T1 then T2. So timestamp means this the simply the each word pass at a time. So and then T3 is going to the good one. So the timestamp denote means that it cannot pass together. So it passed time by time. So we have already got two problems. First one is that what I told, well about variance length, and artificial neural network learn everything together. Everything together means like it can run like this togetherly pass everything. As a result, the sequence is not matter here in terms of this. In the RNN, it goes at a time one word, and after one word competition done, then second word, and each one word is dependent on the previous and what will be happen. But in the ANN, it cannot consider it. And the if we consider the simple architecture, ANN and RNN, both are looks like similar, but it goes back again for this recall the previous one. And and so far this is also we want to see that like, okay, how actually the neural network works or neural network architecture work well. So if we go back to the our slide, we can see this vanilla architecture. So we put an input and then it like what actually what does it mean. Okay, so okay, we just take one from here. Okay, we are trying to draw something like this. So this is our uh, consider the block, and here the previous output t minus 1, and current one is xt. Okay, so each one has weights. So I denoted t, uh, not t, it wo, and it there has also weights wx. So what happened? First of all, okay, wo, that means that the previous weight, and this is comes from the previous hidden layer. So uh, these two are inside, and first of all they add together. So if they perform like this, g minus 1 into and merge this add, and then it pass a activation function. So basically in the uh, RNN, the activation function use 10h, and so after this we got an result, and this is the simple mathematical intuition what actually happened inside the RNN. So that's all about today's today's session, that we introduce with the RNN. So I am not going to deep dive into the LSTM. Next session we will show the LSTM architectures, and then we will uh, show some project code with how actually RNN perform for basically I have planned two projects I want to show with you. First one is prediction, stock market price prediction with LSTM, and secondly one is text classification, and we also describe the necessary thing how a sentence we convert into the word. Like, we know that machine learning or deep learning, they do not understand anything about anything about text. They consider or they understand only the numbers. So before start the training we must convert our data into their language. So far